Hello, my 11th standard students and the 12th standard students ready to clear your backlogs. We are on to the new chapter of center of mass. And then we will move to collisions and momentum. Then we'll go to circular motion and then rotational motion. So that's the flow of the topics ahead in the coming weeks. So get set, go, my dear warriors. It's time to study in today's lecture finding center of mass. What is the concept of center of mass? And also the different formulas for the different geometries of where you have to locate the center of mass. Okay. In the next class, we'll be doing motion of center of mass and system of particles, Newton's law. That is in the lecture 2. Lecture 1 is just locating the center of mass. Hi. All right. Rama, nice to see you back after a long time, I think. Last lecture, I think, oh, maybe for 12th, you were not there. Hi, Chitra. Hi, S3. Welcome, everyone. Hi, Hema, Asekar. Good evening. And let me know quickly in the chat box if you are excited to start a new chapter and ready and geared up. This is your Captain Shreyas, your physics master teacher on the Vedantu JEE English channel, which is the #1 English channel in the country, and giving you quality content, timely content, and guiding you throughout, not just with the lectures, but also important strategies, announcements, news, everything. So make sure you are subscribed on this channel. And if you've forgotten to mark the attendance, please do that right away, right now. And if you're new, make sure that you comment below saying where are you from and what's your name, right? And also, all the regular students and the new students, if you have forgotten to register for MVSAT, it's coming very close now. 4th October, first day, then 11th, 12th October. So make sure you are preparing for it. And if you want a mock test, I will conduct a mock test as well. And yes, lots of free resources you will get the moment you register for the MVSAT examination. Obviously, scholarships, prizes, everything are there. So apart from that, you are getting some free study material. The link for registration is down there in the description box of this video, as you can see right over here. You just need to enter your details and you will be registered and you can start preparing and give the examination on time. The examination will be conducted offline. Online will be happening most likely later on, depending on how many registrations we get. But around 2.5 lakh students roughly give the examination. So it will be a very good, I would say, judge or a benchmark for you to see where you stand in the actual competition. So whether you are 8th, 9th, 10th, 11th, 12th or a dropper student, this is open for all. And depending on which grade you select, you will be given that kind of paper with that particular syllabus. Okay, so let's begin with the class and let's understand what is this concept of center of mass. Now, when I usually use this word center of mass, people think it is just the center. Okay. Hi, Anto. All right. Good evening. Rishwant, excited. Very good. I'm in 12th, Deepan. Very good. A lot of 12 students also clearing their backlogs. Hi, and everyone. Deepan, everybody. Hi, Namadya. Good evening. Good evening. So it is exactly the center. Well, see, it's basically, you can think it's that location where I can balance the body in equilibrium if you talk vaguely. Like, for example, if I take this pen, if I hold it here, it will obviously fall down. If I hold it here, it will fall down. But if I hold it somewhere here, then it stays there. I can balance it, right? You would have done that with a scale also. You try to balance it on a single finger. So that's roughly where the location of the center of mass is. So center of mass means the or rather it's a concept which tells me where the entire mass of the body, not weight, it is the mass, and center of mass is different from center of gravity. Let me warn you in advance. Okay, we do not study center of gravity in JEE, we just study center of mass. Mass is different from weight. Mass is scalar, weight is vector. Mass is amount of matter, weight is the force is a vector, remember that. So two different things. Many people usually use it without even thinking, center of mass is here only, center of gravity, they feel it's the same thing. But no, they are completely different things. Okay, so where the entire mass of the body can be assumed to be concentrated such that, now I will give you the condition in a bit, but before that, let me show that to you in a very simple way. Imagine this is our body. Okay, Chuma, I have just taken this random shaped body. So if I just draw the outline of that particular body, it will probably look something like this. Maybe there are some forces acting on it. And maybe I show this is the net force. Maybe I show this is probably the net force acting on that particular body. Okay, and because of which this body will maybe rotate, translate, I don't know, it could do multiple things, right? This body might rotate, it might translate, right? It can do multiple things. So it can translate, it can also rotate. Okay, now every point on this body will be going in some different weird paths, maybe like this, maybe like this, maybe like this, maybe like this, like this. All these points will be having different paths, but there will be one point on this particular body. There will be one point on this particular body which will go. There will be one point on this particular body which will go in such a way as if that entire force is acting on that particle, and if you concentrate this mass, if you shrink this body into one point mass, if this entire mass of the body was, let's say, m, if you concentrate it into one single mass, and if you apply that same force, net force, you will see that particular mass will have that same motion, that means same acceleration, as that of the point on that particular body. Remember, every single point in over here is going in different paths. Maybe this is going like this, 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 but this point will be moving in a particular direction at that instant. Okay, at that instant, whatever acceleration this point has, the same acceleration that concentrated mass will have with that same net force acting on that body. That is the true location of the center of mass. That is the meaning of center of mass. This is the exact meaning. Lot of times people think you can just condense the mass into one place. But where can I condense? Because I can condense the mass here also. I can condense the mass here also. I can condense the mass here also. So where the entire mass can be assumed to be concentrated. Where can you concentrate it? Such that it behaves as if the such that or you can say such that its motion is similar to the point on the body with the same net force, that is that location. Is that absolutely clear? Now let me give you a simple example to actually visualize this concept, because lot of times I have seen many teachers just directly start with the formula of center of mass. I don't really appreciate that. So say for example, you take maybe some kind of a bat, okay, like this. Okay, this is, let's say, a bat, or maybe some tennis racket, something like this. Okay, some racket which is like this, and you throw it. You get angry, you are not winning the game, and you throw it. So what will happen is, if you look at the motion of all the points on the tennis racket, they will all go in very weird ways. Now I will look at one particular point on that tennis racket, which will go in a parabolic path, like a projectile motion. Maybe it will be somewhere over here, maybe. And there is one point on that entire tennis racket, which will go in a proper projectile path, parabolic path. Rest all points will go in weird ways. Like for example, this might probably go like this, and something like that. I don't know, maybe like this, and then like this. Maybe this point might go like this, like this. So if you look at that tennis racket after some time, maybe you will find this over here and this over here, maybe. And maybe after some time, you might find this racket over here, like this. Maybe after some more time, you might find it over here, like this. Okay, maybe again after some more time, might find it here, like this. So as you can see, the racket is rotating, translating, and all the points are moving in weird paths. So all other particles move in some curved and complex paths, but it is only this particular center of mass. So the motion of the center of mass is as if the gravitational force, because that's the only force, is on it and moves parabolically as it would if it were a point mass, as it would if it were a point mass. This is interesting. Imagine the tennis racket was condensed into one singular point and you throw it with only gravitational force. That point will just go in that orange path, nothing else. It will not go as weird random thing. All other points will go in random manner, but this point will go in a parabolic path. So it is that point on that body which is exactly going in that parabolic path, and that is where you will take the center of mass location to be. And here that external force happens to be the gravitational force. That is your gravitational force Fg, which is mass into acceleration due to gravity. Is that now clear? From this particular example, give me a thumbs up or put up a fire emoji right now in the chat box. Yes, IOQM preparation is definitely useful, Subha, for JEE. I mean, you should do it, especially if you're in 8th standard or 9th standard. That's the right age. I would say you are very fresh and very open for new ideas and actually building those fundamental basics at 9th standard level. Okay, so please start preparing. It will be very useful for you. Okay, great. Perfect. Everybody got it. No problem, Dilip. Just you can rewatch the part which you have missed maybe 5-10 minutes back. Okay. I've explained only these two things, but these two slides took some time because it's very conceptual. Many teachers will not explain this to you. What is exactly center of mass? They'll directly come to the formula. Now, if you ask me where the center of mass could be, all right, for particles, let's say if it is just one point, the center of mass is that point itself. But let's say if I have 2 points, where both the masses are going to be equal, then I know for a fact that the center of mass will be exactly at the middle. Center of mass will be at the midpoint, in this case. Not just that, I will never see the center of mass somewhere here I mean, this is the line joining the masses. Imagine the center of mass is here. It makes sense. If two masses are here, the center of mass will be in between of them, not off them. So it will be also on the line joining the masses, on the line which is joining the masses, line which is joining the masses. Okay, sir, what if one mass is small than the other one and the other mass is big? Then the center of mass will be closer to the heavier mass. Center of mass will be closer to the heavier mass, to the heavier mass on the line joining them, on the line joining them, always on the line joining them. So it kind of makes sense. Wherever the mass is more, the mass concentration will be more towards that side. This is less mass, this is more mass. If it is equal, it will be exactly at the middle. So this is qualitative way of looking at it. But sir, what is the quantitative way? What is the formula of, locating the center of mass? It looks exactly like the section formula of internal division. So when you have a two particle system, and let us take those two particles right now. Let's say this is a line joining the two masses over here, and one of the mass is, let's say, some random mass m1. This is another mass, let's say m2. Now this is on a straight line. Maybe it is x-axis, maybe it is y-axis, or maybe it is z-axis. Okay, I really don't know. So right now I will just take the coordinate to be x1. Okay, and let's not worry about the y coordinate. The coordinate of m2 is, let's say, x2. This is x1, this is x2. Then the center of mass will be somewhere in between, right over here. Okay, I don't know where exactly, but this is where the center of mass would be. And the coordinate will be xcm. Cm stands for center of mass, x is the x coordinate. If this was in the y direction, I will use y variable. If it was z, I will use z variable. That's all. So the x coordinate of the center of mass happens to be equal to nothing but m1 x1 plus m2 x2 divided by m1 plus m2. Now, if you are familiar with some coordinate geometry, or if you have studied, section formula of division of 2 points, then you would remember that this is very much similar or identical to that. It is exactly like that. So having said that, let's block this. This is just for two masses, but we will study for 3, 4, 5 masses also. Don't worry. Right now I'm temporarily blocking it. Same formula in the y-axis, same formula in the z-axis. Wherever x is there, you replace with y or z. So m1 x1 plus m2 x2 by m1 plus m2. This also tells me one important thing, that wherever the mass is more, the x coordinate will shift towards that side. How I can see that? Let's say m2 was more, mass number 2 was more. So m2's weightage will be more. So the x coordinate will go more towards, or the weightage of m2 x2 will be higher if m2 is more. If m1 is more, then the weightage of m1 x1 term will be more. So this term will be more important than this term. So the center of mass will shift more closer towards m1 side if this one is more. So depending on which term is more, you will see that center of mass will automatically shift towards that side. As simple as that. Not just that, this also brings me to a very important definition saying that the center of mass divides the distance between the masses inversely to the masses, themselves. Okay, what does this really mean? Say for example, I will take this particular distance as d1. I will take this particular distance as d2. This entire distance is now divided into two distances, d1 and d2. Guess what? This d1 and this d2 will be inversely related to the masses, meaning this will be M2 and this will be M1. D1 is inversely proportional to M1, D2 is inversely proportional to M2. This is a very important technique which can be used in many formulas, many questions. I will show it to you in a short moment. So this D1 is inversely proportional to M1, this D2 is inversely proportional to M2. What does this really mean? Think. See, if mass number 2 is more, center of mass will be closer to M2. If this is heavier, this will shift here. So D2 will reduce. Makes sense. So if M2 is higher, D2 will reduce, inversely related. If M1 is becoming big, this center of mass will come closer here, D1 will reduce. So if M1 becomes big, D1 will reduce. So again, inversely related. Getting my point now? Everybody clear about this? This is very, very important. Okay. Sir, can I follow PYQ books since there are less PYQs number than it should be? I didn't get your question, Zoro, exactly. All right. It will take some time, W cuts, maybe 1 or 2 months. Yeah. Great. Now, let me show you some examples on this. Say, I tell you, there is one mass here, there is one mass here. Let's say this mass is M, or let's say this is 3 kg, and let's say this is some 5 kg. Let's say this coordinate is 2, 0. Let's say this particular coordinate is, I don't know, something like 18, 0. Chumma, I have taken some random value. And I want to locate where the center of mass is. So obviously the center of mass will be on the line joining them somewhere over here, more closer towards the 5 kg, but it's okay. I don't have to visualize it. So if I want to find the x coordinate of the center of mass, I will use m1 x1. m1 is 3, x1 is 2, plus m2 x2, that means 5 into 18, whole thing divided by m1 plus m2, that means 3 plus 5. Is that okay? 3 2s are 6. 18 5s are 90, right? The whole thing divided by 3 plus 5, which is nothing but 8. So 90 plus 6 is 96. What is 96 divided by 8, my dear warriors? Yes, 96. Stable. Everyone, come on. Everyone. Yes, answer it in the chat box right away, right now. 12. Paka? Very good. So 12 is the answer. So the coordinate will be, so the center of mass, I will write it down over here. So the center of mass is at 12, 0. That's the final answer. As simple as that. Okay. Now I'll give you another question where I will not use this formula. I will use this formula. How? I'll tell you. Imagine I tell you there is one mass of M, and let's say over here the mass is 3 times of M and the distance of separation is D. I want to locate where the center of mass is. Okay, first of all, let me show the center of mass somewhere over here. This is where the center of mass will be, and this distance will be, let's say, D1, and this distance, let's say, will be D2. So what can I say? D1 divided by D2. The distances are inversely divided in the ratio of the masses. D1 will be inversely related to M. D2 will be also inversely related to 3M. That means it is basically 3 by 1. So cross multiplying, what do I get? D1 is 3 times of D2. D1 is 3 times of D2. But wait a minute. But we already know D1 and D2 added together is the total distance D between them. So D1 is nothing but 3 times of D2. Okay. Plus this D2 will be nothing but D. Alright, everyone. So this will become nothing but 4 times of D2 is nothing but D. Therefore, D2 is nothing but D by 4. So if D2 is D by 4, that means D1's value, D1 is 3 times of that. So it will be 3 times D by 4. So we located where the center of mass is. It is at a distance of 3D by 4 from M and at a distance of D by 4 from 3M. So look at the options. Either one of them will be given, either D1 or D2. Mark it. That's how you use the inverse relationship formula. Is that clear? All right. Naga, it will be around 1.5 to 2 hours. Okay. Yes. Perfect. Got it, sir. So now that we know how to find the center of mass of two particles, what will it be for 3 particles, 4 particles, or n particles? And in general, can I give the formula for n particles in a vector form? The answer is yes. So say for example, if you take this as the y-axis, this as the x-axis, this as the z-axis, right over here, okay, and we take multiple particles, discrete means separate. You can count them, okay, you can separate them, small particles, point masses. Let's say you have a point mass m1 here, point mass m2 here, then you have point mass m3 here, okay, and then point mass like that mn over here. So each particle will have some coordinate, and eventually you will find where the center of mass is. Let's say the center of mass is over here. The center of mass is over here. I can also show the positional vector of the center of mass. Maybe this is the positional vector of the center of mass. Other positional vectors of m1, m2, m2, like that, then m3, m4, m5, mn. So many things will be there. So if you ask me what is the x coordinate of the center of mass, instead of just m1 x1 plus m2 x2, it will also have m3 x3. Like that, there will be terms m4 x4 till mn xn, till I reach the last particle. The whole thing divided by m1 plus m2 plus m3 till I reach the nth particle, which is mn. Same thing I can talk about the y coordinate of the center of mass. That will be m1, but this will be y1 plus m2 y2, like that till I reach the nth particle, which is mn yn, and entire mass divided m1 plus m2 plus m3 till mn. Same thing with the z coordinate of the center of mass. It will be nothing but m1 z1 plus m2 z2, like that till mn zn, the whole thing divided by mass 1 plus mass 2, mass 3, like that till I reach the nth mass. So this becomes the formula which I need to remember. Okay. This is the formula which I need to remember. Is this absolutely clear, everyone? X, Y, Z, all the 3 coordinates. Sir, can I convert it into vector form? Very easily. Why not? So if you want to write it in vector form, then the vector of the center of mass, position vector, this is that position vector of that center of mass in IJK format. Bar will be there. So I'm putting that bar, will be mass 1 R1 bar. What is R1 bar? Position vector of mass 1 plus M2 R2 bar, position vector of second mass. Like that, you keep on adding till you reach the last mass multiplied with that vector and divide it with the scalar quantity of the total mass, M1 plus M2, like that till the nth mass. So this is in the vector form. This is the vector form of it. This is the positional vector form. This is the positional vector form. This is nothing but the coordinates. This is nothing but the coordinates. Coordinates in 3 dimension. Coordinates in 3 dimension. We'll apply this and see, don't worry about it, and I will show you how to use this. It's not very difficult. I mean, it's just a layman's work. You can just do it very easily. Okay, right. So let's do some questions on this so that you get a fair idea. Okay, let's start with the with the JEE question itself. Not a big deal. We can definitely do this JEE question, I'm pretty sure. What does it say? 2 bodies are there of mass 1 kg and 3 kg, have positional vectors this and this. This is a 3-dimensional question. The center of mass is given by. Although there are 2 particles, the point is it's a 3D question. But you cannot sit and visualize, so where will it be? Don't worry. Just use our vector form, RCM. But there are 2 particles only. So what I will do is I will write RCM bar will be M1 R1 bar plus M2 R2 bar, whole thing divided by M1 plus M2. Okay, what is the first mass? First mass is 1 kg. The positional vector is I cap plus 2 j cap plus k cap. As you can see, I am putting it one by one in front of you. Divide. Mass number 1 is 1 kg. So put 1 over here. plus, now the second mass is 3 kg, put 3 and 3 over here. Now put the second vector, which is minus 3 I cap minus 2 j cap and plus k cap, I believe. Yes. So that is what I will substitute. M1 R1 is this, M2 into R2, okay, and M1 plus M2 over here. So what will this become? This is nothing but I cap plus 2j cap plus k cap minus 9I cap minus 6j cap plus 3k cap, whole thing divided by 1 plus 3 is nothing but 4. So I cap minus 9 I cap will make it minus 8 I cap. 2j minus 6j will make it minus 4j. Plus k plus 3k will make it again 4k cap. The whole thing divided by 4. Now minus 8 by 4 is minus 2 I cap. Minus 4 by 4 is 1. Minus 1 actually. Minus 1 j cap. And plus 4 by 4 is also 1. So 1 k cap. So minus 2i minus j plus k, which is nothing but B option, as you can see right over here. Yeah, it is exactly this. Minus 2 I cap minus 1 j cap plus 1 k cap. Okay, so that is option labeled B. Understood? Very straightforward. This was asked in JEE 2022. I judge it's very good. Yeah. Is this a system of particles chapter? See, in different books, different topics are kept in different chapters. So center of mass might be there in system of particles. So in JEE, if you see any JEE, proper JEE coaching, they will always teach you not via NCERT split, because the 11th standard NCERT split is the worst split of physics, especially. Okay, so JEE teachers will always follow the traditional flow of H.C. Verma. Okay, H.C. Verma, Halliday-Resnick. So that is the official flow of any JEE. That's how you can, notice whether it's a JEE teacher or JEE class or not. Anyways, coming back now to another question. This is also previous year. I'm directly jumping to PYQs because the PYQs are very simple. Otherwise, I would have taken some simpler questions before this. Okay, 3 particles of masses 50 gram, 100 gram, 150 gram are placed at the vertices of an equilateral triangle of side 1 meter. The xy coordinates of the center of mass will be 3 particles. 3 particles. Okay, so M1 x1, M2 x2, M3 x3. 3 terms will come. Second thing, this is xy coordinates only. So z coordinate will not come. That is the best part. So you can see 2 coordinates are only there. All right. So question is, what is the xy coordinates of the center of mass? Okay, I will make a copy of it. I will solve for x in this sheet, maybe y in the other one. So x coordinate of the center of mass, since there are 3 particles, M1 x1, M2 x2, and also you will have M3 x3, the whole thing divided by M1 plus M2 plus M3. Same thing I can say about the y coordinate. The y coordinate of the center of mass will be M1 y1 plus M2 y2 plus M3 y3, the whole thing divided by M1 plus M2 plus M3. Okay, fair enough. Let's solve now for x first. Which is my first mass, which is my second mass, and the third mass. It's already given. This is my first mass, this is my second mass, this is my third mass. Okay, all the masses are located on the vertices of a triangle. But before going ahead, I think we need to find out the coordinates, or else we'll be stuck. So what we'll do, okay, let's see what is the coordinate of the first mass. The first mass is at the origin, so 0, 0. So the first mass is 0, 0. What about the second mass, guys? It's on the x-axis. The side length is 1 meter. So this is 1 meter. So the x coordinate will obviously be 1. But y-axis coordinate will be obviously 0, as you can see. In M3 mass, the third mass, the coordinate will be as follows. Observe carefully. The x coordinate will be exactly in the middle. So if this is 1, this will be 0.5. So, okay, 0.5. But what about the y coordinate? Well, for that, use this logic. Whatever is the height, this height can be measured using this trigonometry in this particular triangle. This is a right angle triangle. This side length is 1. So the height will be 1 sine 60. Sine 60 is root 3 by 2. So hence I will put over here the y coordinate will be root 3 divided by 2. Is this absolutely clear, my dear students? Most important thing is to find the coordinates. Without that, we are helpless. So I'll mark the coordinates here also. 0, 0. This will be 1, 0. And this will be 0.5, root 3 by 2. Okay, root 3 by 2. All right. Now let's start substituting one by one. Mass number 1 is 50 grams. We'll keep the question in grams because anyways the units will cancel. That is another trick to remember. Don't sit and convert mass of grams to kgs because anyways it will get cancelled, right? Mass is there on the top and bottom. So 50 grams. X coordinate is 0 plus mass number 2 is 100 grams. The x coordinate is 1 plus mass number 3 is 150 grams and the x coordinate is basically 0.5. Whole thing divided by the total mass, which is 50 plus 100 plus 150. Come on, my dear students. This is 0. This is nothing but 100 plus 150 into 0.5. That means half. That is 75. The whole thing divided by 50 plus 150, 200. 200 plus 100 is 300. Okay. So this will become 175 divided by 300. It's divisible by 25. 25 sevens are, and this will be nothing but 25 12s are. Is that right? So 7 by 12 will be there for sure as the x coordinate. Can you see 7 by 12 somewhere in the options? Can you see 7 by 12 somewhere in the options? I can already see it. It's there here. X coordinate. Don't look at the y coordinate. Just look at the x coordinate. It is either this or this. Okay. So either it is 3 option or it is 4th option. Is that clear? Okay. Now, once that is done, we'll find out the y coordinate. What is the y coordinate, guys? How do we find it out? Yes. All right. Focus, guys. Yes, many of you have already started posting the answers, which is very commendable, guys. Very good. Mass number 1 is 0. Mass number 1's y coordinate is also 0. Sorry, why am I saying mass 1 is 0? Sorry, guys. Mass 1 is 50. My bad. Y coordinate is 0. Okay. Plus mass number 2 is 100 grams. All right. The y coordinate is 0. All right. Plus mass number 3 is 150 grams. And the y coordinate is root 3 by 2. Okay. Now the whole thing has to be divided by 50. Mass 1 plus mass 2 plus mass number 3. Okay, let's see what does it become. This is 0. This is also 0. 150 by 2 is 75. So 75 root 3, I believe. Whole thing divided by 200 plus 100, 300. Okay, again, very similar to the previous one. 75 and 300, guys. 75 divisible by 25, 3 times. 300 divisible by 25, 12 times. So 3 by 12, root 3. But 3 is divisible by 12. So root 3 divided by 4, I believe. So root 3 divided by 4, which is right over here. So this and this combined together, the correct option will be option labeled 4. Is that clear now? Because you can see 7 by 12 here also, but this is root 3 by 8. So option number 4 is the right one. Understood how to solve these kind of questions? So some bit of trigonometry was also there and some bit of calculation was involved. Okay, amazing. Center of mass, Deepan, in 2 lectures. Yeah. Today, just finding location of center of mass. Next lecture, motion of center of mass. Collision momentum is separate chapter. Okay, that is separate. Okay, let's go ahead to the next one. This was JEE 2020 COVID question. Let's see how many of you can solve this COVID question. 3-point particles of mass 1 kg, 1.5 and 2.5 are placed on the corners of a right angle triangle 435 centimeters as shown. The center of mass of the system is at a point. Okay, there will be again 2 coordinates located. So I will solve it for x and y separately. But 1 second like that. Let me mark the coordinates. The first mass, let's say over here, has 0, 0 coordinates. I'm just taking this as my x-axis, I'm assuming. Okay, and this as the y. It was not given, I'm just assuming it for simplicity's sake. This mass, second mass, it is at a location of 3 centimeters, y coordinate will be 0. Here, this mass, x coordinate will be 0, y coordinate will be basically 4. Okay, so these are the coordinates and I will use this now. Starting with the x coordinate, I will not write the formula again now. Now by this time you will have that in your head. I will mentally try to do this. Okay. Mass number 1 is 1 kg. Okay. X coordinate is 0, m1 x1 plus m2 is 1.5 and the coordinate is basically 3 plus m3 is 2.5. M3 is 2.5. The x coordinate is 0. Now the total mass 1 plus 1.5 plus 2.5. Okay, how much is this? This is 0. This is also 0. 1.5 into 3. How much is it? 4.5. Okay, perfect. And this one 1.5 plus 2.5, that's 4. 4 plus 1 is 5. Okay, so this is as good as saying 45 by 50. It's divisible by 5 9 times, divisible by 5 10 times. So 9 by 10, which is as good as saying 0.9. 0.9 centimeters. 0.9 centimeters. So 0.9 centimeters means somewhere here. Somewhere here. 0.9. So 0.9 centimeters I can see only in one option. 0.9 centimeters to the right of 1 kg mass. Yes, to the right of 1 kg mass. I will not even solve it. I will directly mark that option and you can see it is absolutely correct. 0.9 centimeters. You don't have to solve for y. Getting my point? In the actual exam, don't even solve because there is only one option saying 0.9 centimeters to the right of 1 kg. Done. Your problem is solved. But if you had to solve it for the y coordinate, this is what you will do. Y coordinate of the center of mass. M1 y1 will be 1 multiplied by 0 plus M2 is 1.5, but the y coordinate is again 0. M3 is 2.5. The y coordinate is, I believe, 4. And this will be 1 plus 1.5 plus 2.5. You didn't have to do it, just showing you in case you had to choose between options if you could not eliminate. 0 and this is also 0. 2.5 into 4, that's 10. And this is 4 plus 1, which is 5, which gives me 2. So 2 centimeters is the right answer. So you can see 2 centimeters is right over here, 2 centimeters, and here 0.9 centimeters. So it is definitely matching. Is that understood, everyone? Clear? Now you are comfortable in finding center of mass of multiple particles, whether it is triangle, square, pentagon, hexagon, doesn't matter. At the end of the day, it is some kind of geometry or some vector form that you will have to use. Okay. So that is the application of this particular formula when you have point masses themselves given to you. But every time things are not that smooth, the things can get trickier, and that is why we are learning this chapter. So let's start with something of where uniform bodies are involved. Okay, uniform bodies. Let's go to that. Now, what do I mean by uniform bodies? Uniform bodies means one thing. It could be maybe in a 1 dimension, 2 dimension, or 3 dimension. If it is 1 dimension, I am talking about linear bodies, where the mass per unit length, that term is called lambda, is constant. Mass per unit length is basically constant. Then you have two-dimensional bodies, which are like sheets, or paper. There you use the term sigma, where the mass per unit area is going to be constant. Mass per unit area is going to be constant. And the third one, three-dimensional objects, which is basically, big bodies, which will have some height, breadth, length, everything. So, they will have definitely some kind of occupy some space. Okay, it could be a sphere, it could be a cube, okay, etc. They will occupy some space. There you use rho symbol, where the mass per unit volume, because they are occupying some space, the volume will be considered. That term will be constant. So that is the meaning of uniform bodies. Uniform means the density, the evenness, it's spread. It's not like one place is more dense than the other place. You are using the same material throughout. Like for example, if you ask me, is this pen uniform? I would say no. Not because of the shape, but because the materials filled inside are different. I know this side is rubber, this side the nib is made of some different plastic, inside there is some sensor, some part is hollow, so it is not really uniform. Okay, if you ask me, is Shreyas Sir's phone uniform? Then obviously it's not, because not just because of the shape, but inside different components are there, some space is empty, some battery is there, so it is definitely not going to be uniform. But if you ask me, sir, is this pad uniform? Even if it is like this, I would say it is uniform. Because why? Because if I cut any part of the sheet, that mass per unit area will be same, sigma. If I take mass per unit area, if I take half part, 1/4 part, or small part over here, or if I take this whole thing, if I divide that mass by that area, I will see it will be the same. 3 kgs per meter square, or 5 grams per centimeter square, whatever it is. So it is having same mass per unit area then. Is this clear? Everybody with me? Okay. Amazing. Great. All right. Sir, for beginners, Manuva, why don't you guys post the questions after the session is over? Many people just ask it in the live and it will get lost. So better post such questions, because it is very important questions what you're asking. Post it in the comment section. I'll reply to them. Okay? Cool. Yes, Dilip, post that question. Perfect. Now, whenever you have a uniform symmetrical body. Now, uniform is different, symmetrical is different. Symmetry means it has identical things on either side. Like, is Shreyas Sir symmetrical? 100%. How? If you imagine a vertical plane like this going through my body, whatever is there on my left side is also there on the right side. Not internally, heart is only there on one side, it is not there on the other side, and some organs might be there here and there. But you can visualize externally, assuming Shreyas Sir is made fully solid, whatever is there on the left is on the right, so symmetrical. Similarly, if I ask you, maybe is this scissor symmetrical? Yes, you can cut it into half. Whatever is there on the left and right is the same. In fact, whatever is there in the front and back is also same. So if you imagine the scissor, it has a line of symmetry. There is this line of symmetry. I have a plane of symmetry. Why don't I have a line of symmetry? See, imagine a line passing through my head and passing through my entire body like this. I don't have a line of symmetry. Why? If I go on this side, I find my right eye. If I go on this side, I find my left eye. But if I go front, I find a nose. If I go behind, I don't find a nose. So it's not symmetrical linearly. So line symmetry means everywhere you go on the opposite sides, you should find identical things, but it is not the case of a human body. But if you take this scissor, definitely it is, except for this notch out there. I'm so sorry, guys. This notch is there. I ignored that. But just imagine for a moment, this notch is not there. Okay, just cover up this notch. So if you look at this, then it has a line symmetry. If you go in the front or back, if you go right, left, if you go here, nothing is there. If you go here also, nothing is there. So if there is nothing on this side, nothing should be there on the other side also. So then it is a linearly symmetric body. Then you can also have point symmetrical object, maybe something like, do I have something? Okay, we'll come to this. Okay, take the cylinder. Okay, this has a plane symmetry also. Like if I can cut into half, this side and this side is same. It also has a linear symmetry. Imagine this is the line symmetry of this. So if I go on the top, bottom, same, left, right, same, this side, same. So linear symmetry is also there. But if I go exactly somewhere in between on this axis of this cylinder, okay, somewhere here, exactly in the middle, okay, somewhere in the middle, you consider the height, you go exactly in the middle here. Then also it has a point symmetry. Like if you go here and here, here and here, here and here, here and here, it's the same. It's a point symmetrical object. It has a point of symmetry. So a three-dimensional body, this is very, very important, okay, or a two-dimensional body can have a three-dimensional body, okay, can have any body, any two-dimensional, one-dimensional, three-dimensional body can have point or line or plane of symmetry. Okay, like I can show this maybe like this. This is a plane of symmetry where maybe something is there like this. So on the other side also, it has the same thing. Okay, something like this. Okay, some three-dimensional object. It could also be a line symmetry, like this. Okay, maybe something like the frustum of a cone. It has a line symmetry. Whatever is there here and here is the same. It also has a plane symmetry, of course, and you can also have a point symmetry for a cube or a sphere. Okay, multiple objects can be visualized for a cube, for a sphere. Is this now clear, guys? Point symmetry, line symmetry, plane symmetry. Now, the theory is whenever the body is uniform, then the center of mass will always lie on the plane or on the line or at the point symmetry. So this is very, very important for uniform bodies only, not anything else. What is uniform? I mentioned here. For uniform bodies, the center of mass lies on the plane or line or point of symmetry. Very, very important. So imagine I find point of symmetry. I have located all the three coordinates, x, y, and z. I know exactly where the center of mass is. Don't have to break my head. Like sphere, cuboid, right? All these things, I know exactly where the center of mass will be. But if I have a line symmetry, then I will just know somewhere on this line it is there. So I might have to locate only one more coordinate of the center of mass. Whether it is here or here or here, I don't know right now. But I know it is somewhere on this line. So instead of finding three coordinates now, I'll be just finding one coordinate. Are you getting my point? How this is helping me solve the problem? So I don't have to look for three coordinates. I just have to look for one coordinate. But when you have a plane symmetry, I know the center of mass will be somewhere on this plane. I need to figure out two coordinates of center of mass, x and y, or y and z, or z and x. One coordinate is for 100% sure what it is. Two more coordinates are needed. Is this clear now, everyone? Why it is working out? Sir, in all uniform bodies symmetrical? No, all uniform bodies may not be symmetrical. Like for example, I make some sculpture like this. Like imagine my pose like this. Shreyas Sir is like this. I am uniform. Imagine I'm fully made of mass. No bones, no air, no liquid, nothing. Full made of mass. Shreyas Sir is posing like this. Am I symmetrical? No. Whatever is there on the left is not on the right. Shreyas Sir's hand is like this. Left hand is like this. I'm looking somewhere here. No. But Shreyas Sir is like this, standing like this, straight. Now I'm symmetrical, although I'm uniform. Okay. Whatever is on the left and right is the same. Now I'm symmetrical. Now I'm not symmetrical. Now I'm not symmetrical. Getting my point? Understood? Everybody with me on this? Absolutely understood. Rama, Chandu, Dilip, everyone. Manav, Deepan, yes, Pranav, Naga, everyone. Understood, Jay? Cool? Okay. No, the Sigma batch price will not reduce. It's done already. And I think the prices, whatever are shown, are the final prices now. Okay, cool. So if you take the example of a rod, where will the center of mass be? It's kind of obvious now. It is exactly the geometrical center. So this is where the center of mass will be. If the length of the rod, is L, then center of mass will be exactly at a distance of L by 2 from either side. If you take a ring, then the center of mass will be at the geometrical center. That is where the center of mass will be, at the center of that particular ring. Look at this, center of mass is outside the body. Lot of times people tell me, sir, center of mass can't lie outside the body. Wrong, it can lie outside the body. You can see the solid chunk is here, but center of mass is outside the body. What about a uniform disk? Again, it's a uniform disk, my dear students. So where will the center of mass be? It's a symmetrical body. So this is where the center of mass will be, at the exact geometrical center. At the exact geometrical center. You take a uniform sphere. Sphere is something like this. Yeah, a solid sphere. Imagine this is completely filled with some metal or some wood or some thermocol or whatever, some solid chunk is there. If you go on the axis exactly at the center, inside of this sphere, that's where the center of mass will be. Okay, it will be inside. This will be inside. This is where the center of mass. It will be inside at the center, of course. Same thing for hollow also. Doesn't matter whether it is solid or hollow. If you have a triangular sheet, triangular lamina. Lamina means, what is the meaning of the word lamina? Lamina means sheet, plane. Okay, sheet or basically a plane, two-dimensional object. The center of mass will be at the centroid. At the centroid. Centroid is the place where the medians will meet. Centroid is the place where the medians of a triangle will meet. So by chance, if this has the coordinates x1, y1, this has the coordinates x2, y2, and this has the coordinates x3, y3, what is the coordinate of the centroid? Maths guys, if you remember your coordinate geometry, you will remember it. It is x1 plus x2 plus x3, whole thing divided by 3. That's the x coordinate. And y coordinate will be y1 plus y2 plus y3, whole thing divided by 3. That is the coordinate of the centroid. Is that absolutely clear? x1 plus x2 plus x3 divided by 3 and y1 plus y2 plus y3, whole thing divided by 3. Those are the coordinates of the vertices. From that you can locate the center of mass. You don't have to do any geometrical construction. Okay, directly you get the answer. Okay, perfecto, amazing, amazing. Now, having said this, let's use this in some kind of problems where you will combine two bodies to locate where the center of mass is, or you will remove one body from the other body, scooping out, which is also called as cavity problems, to find the center of mass of the remaining portion. What do I mean by that? Just say, for example, we take a geometrical structure like this. Chumma, I'm giving some random example, guys. Okay. So this is a geometrical structure. I want to locate where the center of mass is. Okay. What I will do is, first thing, I will think what is this actually. Can I break it down into 2, 3 more smaller pieces? Is it actually made of something more elemental? And I will immediately say, yes, it is definitely made of 2 small things. One is a triangle right over here, you can see. And the other one is obviously that square which is there. Obviously that square which is there right over there. Can you see that? If you can visualize it like that, you have already split that body into 2 smaller parts. This is called as a composed body. What is this particular body called as? This is now called as a composed body. It is composed of two smaller bodies. Maybe that original mass could be something. Maybe I will take this mass as m1. Maybe I will take this mass as m2. So this entire mass will be then m1 plus m2. That is the first step. And then I will also figure out what are the coordinates or axis. I will assume it wherever you want. You can take it. Let's say I take the coordinate axis here and here. There is no harm in taking it here and here also. Okay, you can take it anywhere, guys. Somebody might say, I will take it here and here also. No issues. You can choose whatever coordinate axis. So that is the second step. Choose the axis as per convenience. See the options. Where are they measuring the distance from? Whether it is this vertex, whether it is this vertex, or somewhere from here. Accordingly, choose your coordinate axis. Nobody is going to stop you from choosing it. Once that choice is made, masses also will be distributed. How, by the way, how will the masses be distributed? If you ask me, m1 and m2, if the total mass was m, right? Maybe the total mass would be m. How would that masses be distributed? Think carefully. Just some time back, I told you, when you have uniform bodies, depending on whether it is 1D, 2D or 3D, the mass per unit volume or area or length will be constant. So see whether it is 3D, 2D or 1D object. Accordingly, use that concept to find the individual mass. What do I mean by that? Is, say for example, this is a three-dimensional object. Then what will be constant? The density. If it is a two-dimensional object, areal density, sigma will be constant. This can't be 1D, so I'm ignoring that. So for example, I tell you, for example, rho, I will consider, if it is a three-dimensional object, will be the total mass by the total volume. Total mass by the total volume. Okay. Now, once I get rho, I will use it here. How? This mass number 1 will be that same density, but into volume of whatever this part is there. Mass number 2 will be that same density which I have got over here into the volume 2 of this square like part. If this is 3D. If it is two-dimensional, then I will use sigma. Sigma will be mass by area. And then I will say mass number 1 will be sigma into that area of the triangle. And mass number 2 will be sigma into A2, which is area of that quadrilateral. Understood, guys? Depending on whether it is three-dimensional, you will use this. Two-dimensional, you will use this. So this is basically for your three-dimensional objects. For your two-dimensional, you will use this. This is very important step in determining M1, M2. Once that is done, I will, by logic, think where is the center of mass of this object. It will be maybe here. This is the center of mass of object 1. The center of mass of object number 2 or 3 will be maybe over here. Okay. I will then know the coordinates individually. Okay. It will have some x1 coordinate, y1 coordinate. This will also have some x2 coordinate, some y2 coordinate or z2 coordinate. Now, the total center of mass of the combined object of the composite body or the composed body will be as follows. XCM will be whatever mass is there of the first body, you take that M1. Okay, whatever mass is there of the first body, you take that. Whatever mass of the second body, you take that. Again, divided by M1 plus M2, of course. Same thing for the Y coordinate. You will put M1, M2 and divided by M1 plus M2. This is your Y coordinate. And what will you multiply it with? Obviously, X and Y respectively. So this will be M1, X1. This will be M2, X2. Here it will be M1, Y1. This will be M2, Y2. That's it. That's the difference. So this will give you the total center of mass, X, Y, Z, whatever coordinates is needed. Okay. So what you are essentially doing is you are converting this big body into two smaller bodies. Each smaller body is a point mass here, point mass here. Now you have 2 point masses. These smaller light pink things are 2 point masses, M1 and M2. So the center of mass will be somewhere in between them. That's what you have done. You have used the center of mass formula. Okay, don't worry, I will show you an example to solve this. Let's take an example right over here. Here, look at it. Two identical uniform rods are there, each of length L, and are joined to form a T shape as shown. Locate the center of mass. Given the center of mass of uniform rod is at the midpoint along the length, which is kind of obvious. This T, can you first of all think what is it exactly made of? This particular T can be made, is a composite body. It's a composed body of two separate bodies. I think one body is like this, as you can see, and the other body is like this, as you can see. Okay, so I think both are L. Okay, here it is not looking like both are L. So I guess I'll just try to do this. Okay. Now, since both are length L, if the original mass was 2m of the T-shaped figure, both are identical. Hence, each of these rods will be m and m mass each. Not just that, the center of mass of the top rod will be somewhere over here. This is center of mass labeled 1, and the center of mass of the second body will be somewhere over here labeled 2. I will choose a suitable frame or axis, I would say. I'll choose it here. So let this be my y-axis and let this be my x-axis. So this is x-axis and this of course is your y-axis. So first step of the problem is done. That is what I had told you. Whenever you find a body, first split it and see what is it composed of. Figure out the masses. Here we didn't have to use any formula because luckily they were both identical. So it will be mm only, and then you apply this formula. Okay, so we have to apply the formula. So let's see what do we do next. Now the center of mass of this entire system will be 100% somewhere here. Okay, one thing is clear though. This body is symmetrical about y-axis. So if it is symmetrical about y-axis, center of mass will lie on the y-axis. So y-axis is the axis of symmetry. Is the axis of symmetry. Therefore, center of mass must lie on it. It's a uniform body. So one thing is clear, because center of mass will lie on the y-axis, so the x-coordinate of the center of mass is 100% 0. Is this clear? I'm using this logic which I gave you right over here. The center of mass must lie on the plane or line or point of symmetry. This was a very, very important statement. So definitely by that logic, center of mass must lie on this. So x coordinate will be 0 for any point on the y-axis. Kind of obvious. So only thing remaining is the y coordinate now. So for that, here is what I will do. What is the center of mass coordinate y-wise for this rod? X coordinate is anyway 0. Y coordinate is also 0 because this is itself the origin. X and y are meeting over here. For this point, x coordinate is 0. But what about the y coordinate? If this is L by 2. So this will be minus L by 2. Is this clear, guys? Everyone? Remember, this entire thing was L. This entire thing was L. So only this much part, if you ask me, neglecting the dimensions of that rod. Okay, this is negligible. Ignore that small width. So it is minus L by 2. So therefore, my y coordinate of the center of mass, which will be m1 y1 plus m2 y2, whole thing divided by m1 plus m2. What is mass number 1? This guy, which is m. What is the y coordinate? Well, it is 0 plus mass number 2, that is also given m. What is the y coordinate? Well, it is minus L by 2. Okay, I will put minus L by 2 over here. Whole thing divided by m1 plus m2 means m plus m. So what will this give me? This is 0. This will become minus m L by 2 divided by 2m. Mm cancels, I will get it as minus L by 4. So this is the y coordinate of the center of mass, minus L by 4. So at a distance of L by 4 from the T joint or the T junction, this is the T junction, from the T junction at a distance of L by 4 below, you will find the center of mass. That is the final answer. Okay, that is what it will be. So if you measure it from the below, it will be 3L by 4. From the junction, it will be L by 4. Is that absolutely understood? Yeah, Pakka? Clearo? Amazing, amazing guys. Keep it up, and if you have forgotten to like the video, please like the video right now. Just reminding you, we give such amazing content, you better like it. Okay. Sir, give us another question, sir. All right, I will give you a JEE question only. Here it comes. Let's see whether you can solve this. Okay. A rod of some length is bent at a right angle to form keeping one side length as 2L. Okay. The length is 5L. It is bent one as 2L, one as 3L. The position of the center of mass. Now, this is the place where you will see the mass distribution will not be uniform. That is the interesting thing. Yes, Dilip, that's what we have exactly done in the previous question. We have split the body into two parts. This body is like a point here. This body is like a point here. Now forget that yellow part. Imagine 2 points. Where will the center of mass be? It will be somewhere here. That's what we have done. The center of mass will be here. So we have forgotten that big T, forgotten those rods, just boiled it down to two passes and then combined it together. That is what this entire procedure is all about. You forget the two individual bodies, think of them as points and bring them to 2-point masses to find the total center of mass. Now, look at this particular question. There is one thing strange in this question, which is the masses will not be distributed uniformly. See, one rod is here and the other rod is here. The lengths are not the same. Be careful. So, if I take the total mass to be chumma, I'm taking 5m. Why 5m? Because the length was 5l, right? The length was 5l. So I'm chumma taking it as 5m. Then this rod over here, okay, this rod over here will have a mass of 2m and this rod will have a mass of 3m. This distribution of masses which happened, how this mass got distributed M1, M2 depends on the area, volumes or their lengths. Because this was a linear body, whenever you have a linear body, one-dimensional kind of body, the mass per unit length is the same, and that is the reason why you saw it got divided proportional to the length. 2 length, 2m, 3 length, 3m, 5 length, 5m. Very simple. Got it? This is the very important step, guys. Many people will make a mistake. They will just take m and m over here, which is wrong. And of course, now taking the axis is important. So this is your x-axis and this is your y-axis, standard. Okay. So this is your x-axis and this is your y-axis. But we are not done yet. We have to locate the center of mass of individual rods. We convert this rod into a single point over here. Now, obviously, the center of mass will be at a distance of, if this is 2L, this will be L, I believe. So it will be at L, comma 0, y coordinate will be 0. This is center of mass 1. Is this clear why it is so? Okay, observe carefully. This length is 2L. So 2L's half will be L. So this will be L. Similarly, think center of mass of the second object will be here. Center of mass labeled 2. The y coordinate will be 0, of course, but since this length is 3L, the center of mass will be at a 3L by 2 distance. So this, what is it? I said y coordinate is 0. My bad. Sorry, guys. X coordinate is 0. The y coordinate will be 3L by 2. 3L by 2. Is that okay? Just check this out. X coordinate is 0, y coordinate will be 3L's half part, exactly in the middle. Okay. Vijayan, good evening, but you don't have to spam. You will get blocked by the admin. Okay. Don't spam. Now, let's focus and figure out the location of the center of mass, starting off with the x coordinate first. So x coordinate of the center of mass will be, I'm not putting the formula again, waste of time, m1 x1 will do. Okay, m1 is 2m over here, x coordinate is just L, plus m2 is 3m over here, as you can see, 3m, and x2 is obviously 0 upon total mass, which is 2m plus 3m. How much is it coming out to be? This is 2ml, this is 0 divided by 5m. So obviously it will be 2l divided by 5. Is this absolutely fine? Yeah, everyone? Very good. So 2l by 5, okay, we'll just leave it as it is for now. But wait a minute, L is given to be 10 centimeters. Yes, sir. So substitute L as 10 and divided by 5. So 10 by 5 to 2 2s are 4. So 4 centimeters is the x coordinate. So 4 centimeters I can only see in this particular option. I should directly mark it. Okay, I should directly mark it as the fourth option. Then you can see it is right over here. Don't have to waste your time finding the y coordinate, but if you waste your time, this is how you will waste it. YCM will be m1, m1 is 2m into y coordinate, which is 0, plus m2, which is 3m into the y coordinate, which is basically 3l by 2, whole thing divided by 2m plus 3m. What will this be? 0, and this will be 9 ml by 2, 9 ml by 2, and this will be nothing but 5m, cancels, so this will become 9l divided by 2 5s are 10. But wait a minute, length is nothing but how much? 10 centimeters. So 10 cancels, it will give me 9 centimeters. So which is also right over here. So fourth option is obviously the right answer. So this is how you do the questions. Okay, very good. Others, which batch should I join for next year drop? Next year drop means? Meaning JEE 2026 or JEE 2027? Next, you're dropping this year and preparing for next year, right? So then it is Sigma batch. Manthan batch is our pro batch. Pro is different. Pro is also for droppers, but it has more personalized attention. You get personal teacher, doubt solving specifically, app you get Tattva books delivered at your doorstep, plus more features are there. So it becomes more personalized and very different kind of batch. So the cost is also accordingly adjusted there. Okay, Vijan, I'm very good. Okay, perfect. All right. Moving on now to the next part. We just did bodies which are combined or composed, or they are combined together, they are added together. What about bodies which are having some kind of cavity, or you have to subtract them? I'll give you an example. Imagine, I tell you, there is a sheet like this, and in that I have taken out something somewhere over here. I've taken out something somewhere over here. So if you look at it closely, this is the part which is remaining. So you have made a cavity, or imagine a sphere, inside that you take out something, or any scooping out thing, cavity is there. So in such cases, what do you exactly do? All right. The first thing that you should do is figure out what is it exactly made of. You can imagine this to be, 1 second, this minus a triangle. This minus a triangle. Okay, that is the first thing that I should do. This is equal to this minus this. So this mentally you should think or basically draw it in your rough work. Next thing, figure out the axis that you are going to choose, whichever is your preferred axis. Maybe you can choose this axis. No harm in that, but make sure you are sticking with that same axis, or else you will be messing it up, messing the problem. Somebody will choose X and Y over here, then that is wrong. Okay, stick with the same axis throughout the problem. Okay, so my axis choice is also done. Now comes the next part. Remember masses. Yeah, that is very important. So if the total mass of this guy is m, this mass without the cavity will be m1. This mass will be m2. Please understand, these masses that I am showing over here are without any kind of cavity. This is as if nothing was there inside this. Okay, it's a complete solid block. So first step, figure out what is it made of. It is made of a square or whatever minus a triangle. You mentally make that equation and then start drawing it. Choose suitable axis and represent the masses. This mass can be found, these two masses can be found by density. Can be found by density, depending on whether it's 3-dimension or 2-dimension, just like I have told you before. For example, if it is a 3-dimensional object, m1 will be sigma into v1 and m2 will be rho into v1 and this will be rho into v2. And if it is a 2-dimensional, it will be m1 is sigma into area 1 and m2 will be sigma into area labeled 2. What is sigma or rho? I can say over here, rho is density, which is the total mass by the total volume, and sigma is the mass by the total area of this particular figure. That is how you can do it. Is that clear? So use this for finding m1 or m2. So this is what you will do for 2-dimension and this is what you will do for 3-dimension. This is for 3-dimension, this is for 2-dimension. This much done. Once this much is done, then use your formula. That's it. What is the formula now? Observe carefully. This is very important. Each of them will have their center of mass. Maybe the center of mass of this guy is here. Center of mass of this guy is here. So I'll put COM1 and COM2. Then the center of mass of the entire figure, which is over here, the x coordinate of the center of mass and the y coordinate of the center of mass. So what will it be exactly? First of all, numerator will have something, denominator will have something. Numerator m1, m2, here m1, also m2, here also m1 and then m2, here also m1 and then m2. Then here I'll put the x coordinates, x1, x2. Here I'll put y coordinates, y1, y2. Now here is the tricky part. Be careful. What you will put is not m1, x1 plus, but minus. And here also m1 minus m2. So this minus is that important part. A lot of people miss it, both in the numerator and denominator, because you're subtracting it. So whenever you subtract a mass or you are taking a cavity, it is always a minus. Same procedure till here. You can see same procedure except for this minus part. After that, you have to just put a minus sign. Is this clear? Everyone? Welcome, Mohammed. Vijan, I'm excellent. Okay, how many questions? Sangim, how many chapters are there in physics, man? Barely some 20-25 chapters are there. Okay. How many questions are going to come in JEE? 25 questions. So if you ask me such questions, then I will tell 1 or 2 questions will come, maximum 3 questions will come. All right, that to combined questions, not solo, combined questions. So if I tell you 1 question is going to come, you will feel it is not important. Then you will leave the chapter. Then next chapter you will ask me the same question. I will say 1 question will come. You will also leave that chapter. So like that, every chapter, 20-25 chapters, you will leave off. So barely 25 questions are there. You can expect almost 1 question from every chapter. Yeah. Some chapters might be 2 questions or 3 questions. Okay, right. So let's do this problem. So this was done composite bodies. Now this was with cavity. So let's take up a question on cavity right over here. Okay, let's see if we can do this. Observe. Consider a circular disc of radius 20 cm with the center located at the origin. A circular hole of radius 5 cm is cut out from the disc in such a way that the edge of the hole touches the edge of the disc. Okay, the distance of the center of mass of the residual remaining disc from the origin will be okay. Let's draw it first. This is our circular disc. Okay. I'll draw it here. Okay, and they have told it is located at the origin. That means something like this, I believe. Okay. Then what have you done? You have taken out a portion of it such that the original disc had a radius of 20 centimeter, a hole whose radius is 5 centimeters. Hole whose radius is 5 centimeters will be very small. So somewhere here like this. This is what you have done. Okay. This has been taken out. Now what part is remaining? This much part is remaining. This much part is remaining, and they are asking where the center of mass is. Obviously, the first thing to do in this question is see what is it exactly made of. I think there are 2 things over here. One thing that it is made of is that big disc. It's a disc, right? Yeah, that big disc. And from that, you are taking out a smaller disc. These are the 2 things that you should consider. Okay, so this is equal to this minus this. This is the first step. Coordinate axis is also marked. Perfect. Next step, what I will do, I'll figure out how much each of these masses are. Okay, I'll figure out how much each of these masses are. I know mass per unit area is the same because it's a 2-dimensional object. So keep that in mind. So look at it. It's a disk. So it's a 2-dimensional object. So sigma is going to be same everywhere, mass per unit area. So if you take this guy's mass as m, it will be convenient, I believe. So let's assume the mass is m. So the density will be mass by the total area, and the total area will be pi into r is how much? 20. So 20 square. Okay, so that is sigma. I'll just leave it like that. I'm not going to touch it right now. Now if you ask me how much is the mass of this guy, the mass which has been taken out, so I will call it m prime. I'll just call it m prime. So m prime will be sigma into that area of the area of cavity, that particular area of that cavity. How much is that area of the cavity and how much is sigma? Sigma is nothing but m divided by pi multiplied by 20 square, and area of the cavity, my dear students, that is pi into radius. So radius is given to be 5 centimeters if I'm not wrong. So pi into 5 square. Pi cancels, m is remaining. So I'm just left with 5 by 20 whole square, which is 1 by 4 the whole square. 1 by 4 square is m, 1 by 16. So it will be m by 16. So m prime is m by 16. Perfect. So this is m by 16. That means the original mass would have been, if that cavity was not removed, from m, if you remove m by 16, what will be that original mass, guys? Yes, what will be that original mass? Think about it. What will be that original mass? Yeah, that original mass will be m minus m by 16, which is 15 m by 16. That would be the original mass which is remaining of that original probe. Thank you, Sangam, so much. Class is up to 8 o'clock. I want to go in detail. I do not do one-shots at this point of time. I know a lot of YouTube classes are going on right now. One shot. Everybody is getting very good views and everybody is just looking at one shot thinking, oh, I'm learning everything, but we are not doing that. Okay, so we are going in detail, or else I can complete this chapter in 1 hour also. You can find my lectures, old videos are there. Shreyas Sir has taught center of mass in 1.5 hours also. But I'm spending that 4 hours on this chapter for a reason. Now, once that is done, okay, I'll get rid of this now, not needed anymore. I don't need this also, forget it. Okay, I will use my formula. It has a line of symmetry, I can see, and that line of symmetry is the x-axis. So 100% the center of mass must lie somewhere over here. This is where the center of mass will be on the x-axis. Y coordinate will be 0. Okay, so x-axis is symmetry, is the axis of symmetry. Therefore, the y coordinate of the center of mass will be 0. So we just have to look at the x coordinate of the center of mass. So x is COM, we have to figure out. Okay, so how much is x COM? Well, M1 is M, M1 is M, M2 is M by 16, and I'm taking out something, so minus, upon M1 minus M2. So M minus M by 16. I have to now multiply it with the coordinates. Now, first of all, if you look at this disk, the center of mass will be here. The coordinates will be 0, 0. Correct? This disk, center of mass will be here, but what will be the coordinates? Let's think. See, guys, the bigger disk which was there, it was somewhere like this. We know this radius which was there, that is 20 centimeters. So this is 20 centimeters. This small radius over here is 5 centimeters. So now you can easily guess how much is this going to be. Come on, my dear students. How much will this exactly be? This exactly will be how much? This will be 15 centimeters. Does that make sense, everyone? So out of radius of 20, 5 is taken out, 15 is remaining. This was 20, this is 5. So from the center to the origin, it is 15. Perfect. My job is done. So the first x coordinate is 0. Second is basically 15. Okay, let's see how much is it coming out to be. This is 0 only, minus 15m by 16. 15m by 16. Just check this out. Whole thing divided by m minus m by 16 is also 15m by 16. My goodness, this is just coming out to be -1 centimeter. That means the center of mass is at a distance of 1 centimeter, which is absolutely fine. 1 centimeter. Yes. So don't think about that negative sign. Negative sign just tells me you're on the left side. But distance wise, this distance came out to be 1 centimeter. That distance came out to be 1 centimeter. Everyone clear? Yes, Dilip. The answer is D. Hi, TNT Jupiter. Perfect. Is 2026 going to be tough? Yes, 2026 paper is definitely going to be tough. Okay, because 2025 was tough and 2026 will definitely be tougher. Plus, NTA, you cannot predict, man. Like, the competition is getting crazier. Awesome. Now, I'm going to give you a homework question. Please solve it at home. This is an L-shaped figure. Hint is, think of this L-shaped figure as a big rectangle minus a small rectangle. This was asked in the COVID year. So, use it like that. You can easily solve it. You can also solve it by one more method. You can consider it as this plus this, either via addition, composite bodies, or you can take it as subtraction also. This body minus this body, you take out. So body with cavity also we can do. Either ways, the answer will be same. Okay. All right. I think it's Ria. You should now assume that the COVID era is over. The papers will no longer be simpler. We are going back to the pre-COVID era. 2016, 2017 JEE papers. If you open it now, you'll be shocked to see the difficulty level. So we are slowly moving towards that side, because you can see the NTA also has been challenged. It's also taking revenge. NEET paper physics was so difficult. Yeah, they were asking kind of advanced questions in a NEET paper. So it's foolish to think that JEE mains paper can't be tough. So JEE mains will definitely be not very tough like advanced. Obviously, it will be good level paper like it used to be in 2016, 2017, 2018, 2019, like that. And there will be a good amount of difficulty level gap between the JEE mains level and the JEE advanced level. That is what you should expect in the next 2-3 years at least. So mentally prepare yourself like that. Answer for this question will be there on the next slide, and you can pick it up later on, okay, in the PDF. Now, the last part of today's class is center of mass of continuous rigid bodies. Say, for example, I have some rigid body like this. How many particles are there? Infinite. So I am obviously not allowed to use m1x1 plus m2x2, because when will I stop? How many particles are there? What is n? How many terms will be there? It's meaningless. So whenever such things happen, what you do is you divide that mass into small particles and you call each mass as dm. It's an elemental mass. Elemental mass. The total mass of this body will be m, and you can say that total mass m can be found by integrating this dm. Basically dm, 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 dm. If you add those masses, that is integrating them, you will get the total mass m. Now, if you are interested in the x, y or the z coordinate, so for example, the x coordinate, instead of summation, I will have to put integration now. So it will be integration of x coordinate of this dm mass. Remember, this dm mass will have some x, y and z coordinate. So x into dm upon the total mass, which is integration of dm. Same thing, I can talk about the y coordinate of the center of mass, also the z coordinate of the center of mass. I will use integration now, not summation. So integral x into dm, and here also dm, sorry, not x, this will be y. This will be y into dm's integration, and this will be integral dm. This will be z coordinate into dm upon integration of dm. So this becomes my final formula. How to solve the integration, what limits to be taken, that you can figure out from case to case basis, situation to situation. Okay, dm mass can be a ring, it could be a arc, it could be a line, it could be a sheet, it could be a disc, it could be anything. It depends from a question to a question what you want to take that element to be. But that element should be such that you should know where the center of mass lies for that element. So you are breaking that big figure into small slices and then trying to figure out where that total center of mass is. All right, great. You have seen my videos about revenge, so you should be mentally prepared. How many classes will be there for 20 days and batch? 2 classes, Sam, you can see for subject. So 2 physics, 2 chemistry, 2 maths. Same thing for 12th, 2 physics, 2 chemistry, 2 maths. It fills up the entire week just taking this. Every day 2 classes are there. 11th, 12th. 11th class is at 6 o'clock. 12th standard class is at 8 o'clock. Every day you are having 1.5 hours, 2 hours classes. Okay. I'm so glad, Sangeem, you said that. It made my day. My classes are on Monday, Tuesday, Wednesday, and Thursday. That's my schedule usually. So Monday, Tuesday, I take 8 o'clock, 12 standard portions. Wednesday, Thursday, I take 6 o'clock, 11 standard portions. That is my usual schedule. Remaining days, Diksha ma'am for chemistry and Namrata ma'am for mathematics, 6 o'clock and 8 o'clock. Okay, perfect. So that's the timetable we have been following. Now let's do a beautiful question. I'm directly jumping to a PYQ because I feel we can directly do that. I have that confidence in you and me. Okay, a rod of length L has some non-uniform linear. Non-uniformity came means integration came. Bring it into your head. Density is a function. I mean, it's like screaming and telling me integration is there. Density is a function. A plus B x by L whole square, where A, B are some suitable constants. A and okay, 0 is less than equal to x, less than equal to L. Yes, makes sense. The rod's length is L. So x will lie somewhere between 0 and L only. All those points. The value of x of the Center of mass is how much? Okay, let's find out. First, let me draw the rod. Here the diagram is not so crucial, so I'm just giving it less priority. Okay, so that is one thing. And then this is the y coordinate, sorry, y axis, my bad. And this is your x axis. Okay. Now you break it down into small elements. You take one small element over here. That mass will be dm. The x coordinate will be x only, obviously. The total length of that rod is L. That's the reason why you can see this condition has been mentioned, 0 less than x less than L. So x can go from here till here. And everywhere the density is different. The rod is made of some non-uniform mass by some means. It doesn't matter how, but let's assume that the density function is given. The linear mass density is given. That means lambda is given. So if you consider lambda over here, lambda is the mass per unit length. This mass dm will also have its length, this width which you can see over here. This width which you can see, that width will be dx, small width. You break that rod into slices. You break the rod into slices. Each slice, smallest slice, dx width, small disc-like figure will come. It is having dm mass. Okay? Fine. So lambda is dm by dx. Therefore, from this we get therefore dm is equal to lambda dx. Therefore, dm is equal to, lambda is mentioned, it is a plus b x by l whole square. So that means b by l square into x square, and this multiplied by dx, that same dx over here. So this is what dm is. How did we get that? Because this is given. Sir, will this always be given? Can this equation change? Yes, this will be always given to you, and this might be different. It could be ax plus bx cube, ax minus bx raised to 5, any function, a sin x, could be any function. It's just a function. How that density is changing, that's all has given to you. Is that absolutely clear? Okay, fair enough. Now what do we do, sir? Now is the next step. What is the next step, sir? The next step is using our formula, bro. xcm is integral x dm whole thing divided by integral dm. Oh, perfect. So do I know dm? Yes. Or else I can't integrate. Don't say x dm's integration is x square by 2. I've seen that happen. Silly mistake. You can't integrate x with dm. You have to convert dm into dx. Variable transformation has to be done. Okay, sir. So I'll put x over here. dm, that, my God, such a big thing. That ghost, I will take it over here. A plus bx square by l square, and this whole thing into dx. This whole thing, my God, crazy integration, guys. So a plus bx square by l square, and this dx. There is one small thing remaining, which is the limits. Okay, it's not a definite, it's not an indefinite integration, it has to be definite. So limits. How will the limits be chosen? Look over here. My first mass will start here. I will take all the slices from here till the very end. So the first x coordinate will be 0 and the last will be L. And it's also kind of obvious from this particular information. These are the limits of the integration. So 0 to L and 0 to L. So we have to be a little bit careful while doing this integration. Since this job is done, I will just erase this. I have kept it on the previous slide. Okay, right over here. Okay, let's see what does it turn out to be. So xcm will be, okay, we have a big numerator now. Two terms are there. X dx is the first term. Integral of x dx is the first term, plus I'm separating out the integration. B by L square being a constant is outside, and I'm left with x square into x, which will make it x cube dx. Okay. And here also I will have, oh, I think I missed out a over here. this A is over here. Yes, now is it fine? Okay. This A will come outside and I'm just left with integration of dx, I believe. Integration of dx and plus, again, b by L square is outside. It's a number constant. So integration of just x square dx. Integration of x square dx. Looks scary, but it's okay. 0L, 0L. If you want to write the limits in the end also, it's fine. Okay. Is equal to this big denominator. Okay. A is as it is. We'll do the mental calculation only now. X's integration will be x square by 2. Its obvious limits are L and 0. So after the limits, it will be L square by 2. Okay. I'm skipping one step. You can mentally do that at this point of time. Okay. If you are not able to understand, then you have to go back to basic mathematics and just write one more step over here. This is x raised to 1. X raised to 1's integration is x square by 2. First I will put L, then I will put 0. So if I put 0 also, it will be 0 square by 2. It's no point writing it. So I'm just ignoring that part. Plus b by L square. X cube's integration will be x raised to 4 by 4. So first put x as L, so L raised to 4 by 4. And then if you put 0, anyway some 0 raised to 4 by 4 will come. No point only writing it. So I'm skipping that. Here, A will be there. Integration of dx is x. First put x as L, then put it as 0. So L minus 0 is L only. Plus b by L square. X square's integration is x cube by 3. X cube by 3 means L cube by 3 minus 0 cube by 3, but that is no point writing it. Okay, so we got it over here. So what is this exactly? You have A L square by 2 plus L square will be remaining. So B L square by 4, whole thing divided by, you have A L over here and L square and L cube, L will remain. So B L divided by 3. I can easily see the value of L will get cancelled. This square and square, only one L will remain on the top, which can be also taken common from both of them. So L will be common. I think the options also have some things like that. And you have A by 2 plus B by 4, whole thing divided by A plus B by 3. A plus B by 3. Obviously, we have to take the LCMs. It's kind of obvious now. We have to take it, look at the options. So L will be there. Take the LCM. This will be obviously 2A plus B, whole thing divided by 4. Whole thing divided by, this will be 3A plus B, whole thing divided by 3. Now this 3 will go on the top, 4 will stay here. So that will make it 3L divided by 4. 4 will stay below, 3 will go on the top, so 3L. And here we have 2A plus B, whole thing divided by 3A plus B. So this is the answer. This is the answer. 3 by 4, 2A plus B, 3A plus B, L, which is option number 4. Clear, guys? Everyone? Yes, option number D. So this is how the questions are on integration, where some function will be there and you have to integrate. We'll do more numerical practice in the days to come, but I hope you got the idea. Now, using this technique only, what they do is they find the center of mass of different bodies like a sphere, cone, ring, arc, everything. So the method is the same, but mainly for mains level, if you just remember the formulas, it's more than sufficient for you. So for example, you take a uniform solid hemisphere. Sphere is different. Hemisphere means half of a sphere. So if you take half of a solid sphere, like a cut apple, if you take an apple, it's like a spherical body almost. Half of the apple is the hemispherical, or a guava. Okay, that guava or chiku if you take, or sapota, right? What they call. If you cut it into half, that's a half solid sphere. That is a hemisphere. Then the center of mass is at a distance of 3r by 8. What is the distance? Very important, guys. 3r by 8. So from the base, that is 3r by 8. R is the radius. If you take a hollow is like inside part is scooped out. Imagine you take the orange, only the peel is there, but half of the peel is there. The remaining half would have made it a complete sphere. Only half of the orange peel is there. The inside orange has been scooped out. Or a bowl, right? In which you take soup or some gravy or whatever. It's like a hemisphere. So that center of mass from the base is at a distance of the radius by 2. You should know this. All of this comes by the integration formulas. So this one, please keep in mind, this is solid hemisphere. This one is hollow hemisphere. Okay, solid versus hollow, r by 2 and 3r by 8. The next geometry is for a solid cone, and then hollow cone. For a solid cone, the center of mass from the base, here it is marked little wrong, is at a distance of h by 4, whereas for a hollow, it is at a distance of h by 3. Very crucial again. So all these things you should know. H by 4 versus h by 3. Is it clear, my dear students? Remember all of these formulas. I'll repeat. For a solid hemisphere, 3r by 8. For hollow hemisphere, it is r by 2. For a solid cone, it is h by 4. For a hollow cone, it is h by 3 from the base. Everything is from the base, not from the vertex. Keep in mind. Now, the last thing is arc and a sector. This is very important. Many people do not give you this formula. I'll tell you what this is. Imagine. Imagine some arc like this, a wire which has been bent, okay? And another diagram. This is a sector. The difference is this is completely full inside. This is a sector, this is an arc. You want to locate where the center of mass is. If you visualize clearly, this wire which is bent, if it was straight, it will be at L by 2. You are bending it, so it will shift somewhere over here. This is where the center of mass will be. Center of mass of this guy will be somewhere over here. Okay, fair enough. Now, what you need to do? What you need to do to locate the center of mass? First thing, join the ends to the center. Here though it is already joined. And divide the diagram into two equal parts. The center of mass must lie on that line of symmetry. This is the line of symmetry. Obviously, the center of mass must lie on that line of symmetry. Let's say this entire angle is theta. This entire angle subtended is theta. And the radius is r. Here also the radius is r. Then the distance where the center of mass is located, like this distance, okay, this distance of center of mass, or you can say this distance of center of mass. In this case, the distance of the center of mass is given by, you take the radius multiplied by sine of theta by 2 and then again divided by theta by 2. That's it. That's the answer. Sine of entire angle theta, sine theta by 2 and the entire angle theta by 2. Here the formula is very much similar. You put r multiplied by sine of theta by 2 and again divided by theta by 2. Only difference is you put the number 2 by 3 over here. 2/3. That's it. Whatever is this answer, 2/3 of this will be the answer of this. That is the formula. Okay. So all these things, this formula, then this formula, this formula, you should all by heart this. Okay. All this is very, very important. Okay, clear guys? I'll show you the usage of this maybe for a semicircular ring and for a disc. That will be good enough. This is an arc. It's a ring, semicircular ring. As you can see, the total angle is pi radian and the radius is r. Never put the angle in degrees. This formula, by the way, never put theta in degrees, always in radian. Okay, right. Sir, please explain shifting center of mass. Dilip, that will come in the next class where motion of center of mass will come. Person is walking, how much should the boat move by so that the center of mass stay there, those kind of things. Or one person goes here, other person goes here, how much the center of mass shifts by. That is motion of center of mass, lecture 2. Okay, so we'll wait for that. Anyways, now these are the edges. You divide the entire arc into two parts. So this is the line of symmetry. So I know for sure the center of mass will be here and the center of mass will be located at some distance over here from the center. That is what I did. So this DCM, use our formula. R is there, sine theta by 2, theta is pi, so pi by 2 by pi by 2. Theta is pi over here. Theta is pi over here. What is sine of pi by 2? Sine of pi by 2 means sine of 90. Sine 90 is 1. And this pi will come over here. This 2 will go over here. So this will become 2r by pi. So don't have to really remember 2r by pi separately. If you know this formula, you can get it. Now, the advantage of remembering this formula is that not just semicircle. Imagine even if it was a quarter circle, then also I know the center of mass will be somewhere here on this line of symmetry. Here the pi angle will be pi by 2. That's it. So you can get any kind of question you can solve. Because many people remember for semicircle separately and all of that, waste of time. Remember the God formula. Let's use it over here also. This is a semicircular disc. As you can see, the total angle is pi radian and the radius over here is, let's say, r, and these are the edges. This is the line of symmetry, as you can see. So the center of mass has to lie somewhere over here. The center of mass has to lie somewhere over here. This is the distance of center of mass from the center. So this distance of center of mass, because it's a sector, it will be 2 by 3 r sine theta is pi over here and again pi by 2. Never put angle in degrees, always in radians. So 2 by 3 is there, r is there, sine 90 is 1, pi is there, 2 will go on the top, 2 2s are 4, so 4r by 3 pi. That is the answer. So this distance is 4r by 3 pi. I'm so glad, Dilip. Yes, those are 16 lucky people. But I know a lot of people, lucky people, also watch my lectures recorded, and that's what you will see even in my old lectures. People watching, doesn't matter. People eventually come and watch 20,000, 30,000, 50,000, 1 lakh. That's how it goes. And I'm very happy, guys, you watch it eventually. Venkata, welcome. Good evening. Good evening. Yes. So that is for solid bodies, and that was the last part of today's session. I hope you enjoyed it. Next lecture we'll do motion of center of mass and system of particles, Newton's law. Okay, all those things. Okay, make sure you solve the homework question and put up the answer in the comment section below. Like this video. If you're not yet liked, please do that and subscribe to the channel. This is the #1 JEE English channel in the country, and this is your Captain Shreyas, guiding you, mentoring you, teaching you till the very end. Thank you so much. Bye bye. Signing off.